You're standing in Norman mud at 11:47 p.m. on June 12, 1944, 6 days after D-Day, watching your 7th Sherman tank burn this week. The crew is dead, all 5 men cooked alive when German Panzerfaust round punched through the Sherman's belly armor as it climbed over hedgerow trying to advance through bocage countryside that's turned Normandy into graveyard for American armor. You're Sergeant Curtis Culin, 102nd Cavalry Reconnaissance Squadron, and you're a mechanic from Cranford, New Jersey, who fixed cars before the war and now fixes tanks that keep getting destroyed by landscape features nobody in Allied planning bothered to mention. Hedgerows. Not decorative garden hedges, but 15-foot-tall walls of earth, stone, and centuries-old roots that Norman farmers built over generations to mark property boundaries. Some are thick as cars, roots penetrating 10 feet deep, creating natural fortresses that cover Normandy like labyrinth specifically designed to kill Sherman tanks. The mathematics are brutal and simple. Every time Sherman attempts climbing over hedgerow to reach next field, tank tilts backward, exposing thin belly armor, most vulnerable part of entire vehicle. German infantry positioned on opposite side with Panzerfaust anti-tank weapons simply wait. Moment Sherman's underside appears over hedgerow crest, they fire. 1 shot, 1 kill, almost guaranteed. In 6 days since D-Day, your battalion has lost 23 tanks this way. Not to German panzers, not to artillery, but to landscape features and infantry with handheld weapons. Allied advance that was supposed to be 30 miles inland by now has stalled at barely 3 miles from beaches. Every field is separate battle. Every hedgerow is death trap. And you, mechanic with no engineering degree, are sketching ideas in grease-stained notebook while officers with West Point educations hold meetings discussing problems they can't solve. Your commanding officer, Captain Samuel Morrison, finds you at 12:14 a.m. still staring at burning Sherman, still sketching. Culin, that's the 3rd night you've stayed up drawing instead of sleeping. What exactly are you working on? You show him notebook filled with rough diagrams, Sherman tank with steel prongs welded to front, angled downward, designed to dig into hedgerow at base rather than climbing over top. Sir, problem isn't hedgerows themselves. Problem is we're going over them instead of through them. If we could cut through at ground level, tanks never expose belly armor. Germans can't shoot what they can't see. Morrison examines sketches skeptically. Culin, Allied engineers have been studying hedgerow problem for 2 weeks. They've proposed explosive charges, modified bulldozers, artillery bombardment. None work consistently. What makes you think welding scrap metal to tanks will succeed where trained engineers failed? Because engineers are thinking like engineers, sir. They're designing complex solutions. I'm thinking like mechanic. Simplest solution that works is better than complicated solution that doesn't. You point at diagram. These prongs, just steel beams from German beach obstacles, Czech hedgehogs they planted to stop our landing craft. We captured thousands. They're hardened steel, already shaped right, scattered all over beaches doing nothing. I weld 4 of them to Sherman's front at 15-degree downward angle. Tank rams hedgerow at speed. Prongs dig deep, create leverage, rip through earth and roots. Tank plows through instead of climbing over. Frontal armor stays facing enemy throughout. Germans can't penetrate frontal armor with Panzerfaust. Morrison is quiet for long moment. Around you, medics are still working on casualties from today's failed advance. Stretchers carrying bodies pass nearby. Finally, Morrison speaks. How long to build prototype? Give me damaged Sherman welding equipment. 2 days. I'll have working model ready for testing. Culin, if this fails, we've wasted 2 days and resources battalion can't spare. If it fails catastrophically during test, we might kill crew and destroy tank we could have repaired for conventional use. You meet his eyes steadily. Sir, if we don't try something different, we're killing crews anyway. 7 Shermans lost this week, 35 men dead, all because we keep doing same thing expecting different results. My idea might not work, but current approach definitely isn't working. Morrison makes decision that will either end his career or change Normandy campaign. You have 48 hours. But Kulin, if your contraption gets anyone killed, both our asses are court-martialed. Clear? Yes, sir. Won't happen, sir. Next morning you begin work that will either prove your genius or confirm everyone's suspicion that you're insane. First step, acquire damaged Sherman. That's depressingly easy. Tank graveyard near beach has dozens of Shermans hit by German fire, some repairable, some total losses. You select one designated Fury 2, hit by 88mm shell that destroyed turret but left hull and drivetrain intact. Crew died, but mechanical components are salvageable. Tank can move, which is all you need for prototype. Second step, acquire steel for prongs. You walk to Utah Beach where initial D-Day landings occurred, now transformed into massive supply depot. Beach is still littered with German defensive obstacles, Czech hedgehogs everywhere. These are steel anti-tank barriers made of 3 heavy iron beams welded together in shape of giant jacks. Each beam may be 4 feet long, hardened steel designed to stop Allied armor. Germans planted thousands, assuming they'd prevent tanks from advancing off beaches. They failed at that purpose, but they're perfect for yours. You requisition acetylene torch and cutting equipment, begin systematically dismantling hedgehogs. Each hedgehog yields 3 usable beams. You need 4 beams for prototype, plus spares for testing. Working through afternoon heat, you cut apart 7 hedgehogs, trim beams to precise 4-foot lengths, sharpen tips with grinding wheel borrowed from engineering depot. By evening, you have 4 hardened steel prongs ready for attachment. Technical Sergeant Mike Kowalski, welder you've recruited for project, examines steel skeptically. Sarge, these are German beach obstacles. Command's gonna love that we're welding enemy equipment onto American tanks. Command can complain after it works, you respond. Steel's steel. Germans made good steel. We're just repurposing it for better use than they intended. Night work begins, welding prongs to Sherman's front hull. This is delicate operation requiring precise calculations. Prongs must be positioned low enough to dig into hedgerow base, angled correctly to create cutting action rather than just pushing, spaced wide enough to rip through broad section, and reinforced strongly enough to withstand impact forces of 30-ton tank hitting solid earthwork at speed. You've done math repeatedly. 15-degree downward angle provides optimal penetration. 4 prongs spaced 30 inches apart covers sufficient width. Welds must be reinforced with steel plates to distribute stress. Any mistake, wrong angle, weak weld, improper spacing, means prototype fails, possibly catastrophically. Kowalski questions every decision. Why 15 degrees? Why not 20? 20 degrees digs too deep, creates excess resistance, might stall tank or snap prongs. 15 provides balance between penetration and forward momentum. Why 4 prongs instead of 3 or 5? 3 doesn't cover enough width. 5 adds unnecessary weight and complexity. 4 is optimal for weight distribution and cutting coverage. Hours pass. Welding torch creates brilliant flashes in darkness, sparks cascading like fireworks. Other soldiers gather to watch, making jokes. Kulin's building Frankenstein tank. That thing looks like pig mating with porcupine. $5 says it falls apart first time he hits anything. You ignore commentary. By dawn on June 14th, your 48-hour deadline, prototype is complete. Sherman, Fury 2, now has 4 steel prongs extending from front hull like tusks of mechanical beast. Design looks crude, improvised, nothing like sleek engineering solutions official channels would propose. But crude solutions sometimes work when elegant ones don't. Captain Morrison arrives at 0600 hours to inspect. He walks around modified Sherman silently, examines welds, tests prong strength by hitting them with sledgehammer. Finally, Sergeant, your creation looks insane. But I've seen plenty of insane things work in this war. We'll test it at 0800. Find yourself a volunteer crew because I'm not ordering anyone into that thing. Finding volunteers proves easier than expected. Word has spread about Kulin's crazy hedge-cutting tank. Corporal Jake Mitchell, driver whose previous Sherman was destroyed in Hedgerow Crossing, volunteers immediately. Sarge, I watched my last tank burn, trying to climb hedges the normal way. Your way can't be worse. Gunner Sergeant Tom Harrison. If this works, maybe I stop watching friends die. If it fails, at least we tried something. Loader Private Danny Chen. Everyone says you're mad, Sarge. But sometimes mad ideas are only ones that work. At 0753 hours, test site is established. Particularly massive hedgerow selected specifically for difficulty, 15 feet tall, roots penetrating deep, exactly type that's been killing Shermans for week. Officers gather to observe, including Captain Morrison and Major Jack Williams from Division HQ. Betting pools form among enlisted men. Will prototype work, fail harmlessly, or explode spectacularly? You position yourself in Commander's cupola of Fury 2, monitoring everything. Your heart pounds. If this fails, 48 hours of work are wasted. Opportunity is lost. Current deadly stalemate continues. If it succeeds, you might save hundreds of lives by giving tankers way to breach hedgerows without exposing themselves. Mitchell's voice through intercom. Ready when you are, Sarge. You take breath. All right. Approach hedgerow at 20-degree angle, 30 yards out start acceleration, hit it at maximum speed. Don't hesitate, don't slow down, commit completely. Roger that, committing completely. Engine roars. Black exhaust pours from Sherman's exhaust stacks. Tank lurches forward, gathering speed. 30 tons of steel accelerating toward immovable object that stood for centuries. Impact is thunderous. Earth explodes outward. Roots snap with sounds like rifle shots. Sherman shudders violently, throwing you forward against cupola rim despite restraints. For terrifying moment, tank seems to stop, embedded in hedgerow mass, engines screaming, tracks throwing up huge dirt clouds. Then, slowly at first, movement. Prongs are working. They've dug deep into ancient earthwork, creating leverage points. Steel teeth driven by tank's momentum are ripping through compacted earth and root systems that have defeated every previous attempt. Tank tilts forward slightly, maintaining nose-down attitude that keeps frontal armor facing potential threats on opposite side. Never once does belly armor expose. Roots continue snapping. More earth cascades off hull. Engine screams with effort, and then suddenly, breakthrough. Sherman bursts through opposite side of hedgerow, emerging into field beyond. You've created perfect breach, wide enough for other vehicles to follow, low enough that tank never exposed vulnerable underside during crossing. Observers erupt in cheers. Mitchell's voice through intercom shaking with excitement. It worked! It actually worked. You climb out, legs weak with relief. Captain Morrison approaches, expression unreadable. Sergeant Cullen, that was either bravest or stupidest thing I've witnessed in this war. Possibly both. Then he smiles. But it worked. Your insane contraption actually works. Major Williams steps forward. Sergeant, how many of these modifications can you produce? How quickly? Sir, with enough welders and access to more Hedgehog steel, my crew could modify 10 tanks daily. Maybe more if we streamline process. Not good enough, Williams responds, and your heart sinks. Then he continues. I'm assigning you 50 welders and unlimited access to beach obstacles. I want 100 tanks modified within 1 week. And I'm sending urgent report to General Bradley immediately. This innovation changes everything. Over next 5 days, transformation happens that will alter entire Normandy campaign. Major Williams requisitions 50 welders from engineering battalions across 1st Army. They arrive at your makeshift production facility, field near Utah Beach, transformed into assembly line operating around the clock. You become teacher, trainer, quality controller. Each welding crew receives identical instructions. 4 prongs, 15-degree downward angle, precise spacing, reinforced welds. This isn't complicated engineering, you tell assembled welders at first training session. It's careful craftsmanship, Every weld has to be perfect because tanks' crews' lives depend on your work. One weak weld, one incorrect angle, someone dies. Understand? They understand. Production begins immediately. First day, 8 tanks modified. Second day, 12. By third day, crews have streamlined process enough to complete 15 tanks daily. You inspect every modification personally, checking angles with protractor, testing welds with hammer, ensuring specifications are exact. Some you reject, ordering rework until standards are met. Welders complain about your perfectionism, but Mitchell, whose crew tested prototype, shuts down complaints instantly. Coulin's picky because he knows what happens if this fails. I was in that first test. If angles were wrong, we'd be dead. Let him be picky. By June 20th, 60 modified Shermans nicknamed Rhino tanks by crews who think steel prongs resemble rhinoceros horns are ready for deployment. Major Williams briefs tank commanders. These modifications give you capability to breach hedgerows without exposing belly armor. But they're unproven in sustained combat. First units deploying with rhinos will be testing them under fire. Expect problems, report issues immediately so Sergeant Coulin can implement fixes. That night, you can't sleep. 60 tanks now carry your modification. Hundreds of crew members depend on design you created in 48 hours using scrap metal and improvised calculations. What if you missed something? What if prongs fail under sustained use? What if German anti-tank weapons have developed countermeasures you haven't anticipated? Captain Morrison finds you at 0200 hours still checking welds on tanks scheduled for morning deployment. Coulin, you've checked these tanks 6 times each. They're ready. You need rest. Can't rest, sir. If something fails tomorrow and crews die, that's on me. Morrison sits on Sherman's front glasses near your steel prongs. Sergeant, you solved problem that was killing us. Your invention works. We proved that. But you can't guarantee 0 failures in war. Equipment breaks, circumstances change, enemy adapts. Best you can do is build things right and trust soldiers to use them properly. You've done your part. Now let them do theirs. You know he's right, but guilt doesn't respond to logic. Combat test comes June 21st, 1944. First Rhino tanks deploy toward German strongpoint that's blocked Allied advance for week. You're ordered to observe from battalion command post, but you ignore orders, instead climbing aboard Lieutenant Paul Anderson's Sherman as technical advisor. If your modification fails under fire, you need to witness failure directly to understand and fix problems. Target is German defensive position protected by 3 hedgerows in succession, exactly type of obstacle that's been killing Sherman crews. Standard attack would involve trying to climb each hedgerow, exposing belly armor 3 separate times. Anderson's plan uses Rhino Cutter differently. Breach all 3 hedgerows rapidly, using speed and surprise to overwhelm defenders before they can respond effectively. You're positioned in Loader's station, watching everything through periscope. Anderson's voice through intercom. All right, we're approaching first hedgerow. Sarge, any last-minute advice? Hit it at slight angle, maintain speed, don't hesitate even if impact feels wrong. Trust the prongs. Roger that. Trusting the prongs. Impact comes hard, earth exploding, roots snapping, tank shuddering violently. But breakthrough is fast, maybe 8 seconds from contact to emergence on opposite side. No exposure of belly armor. Germans positioned behind first hedgerow are caught completely by surprise. They're expecting Sherman to climb over, giving them belly shot. Instead, Rhino bursts through at ground level, main gun already firing, eliminating machine gun nest before defenders can react. Second hedgerow breached identically. Rapid penetration, no exposure, German defenders neutralized before understanding what's happening. Third hedgerow is thicker, older, roots deeper. Impact is massive. For terrifying moment, tank seems to stall, embedded in ancient earthwork. More power, you shout. Don't let momentum stop. Anderson floors, throttle. Engine screams, tracks churn, and slowly, agonizingly slowly, Rhino pushes through. Prongs are working perfectly, digging deep, creating leverage. But this hedgerow is testing design limits. Then, breakthrough. Sherman emerges into field beyond, surprising German Panther tank positioned in hull-down defensive position. German crew is reacting slowly. They're positioned to engage Sherman climbing over hedgerow from above, not appearing through hedgerow at ground level. Anderson's gunner fires first. Armor-piercing round strikes Panther's side armor, penetrates, brewing up German tank before its gun can traverse to engage. Mission accomplished. 3 hedgerows breached rapidly, German strongpoint eliminated, 0 American casualties. Anderson's crew emerges from Sherman, faces showing mix of shock and elation. "That was insane," Gunner Tom Barrett says. "We just did in 5 minutes what battalion's been trying to do for a week." Anderson approaches you. "Sarge, your modification works. Not just in controlled test, but against real German positions under actual fire. This changes everything." You inspect prongs carefully, some bending from repeated impacts, minor stress fractures forming near welds on 4th prong, but nothing catastrophic. Design needs refinements, perhaps thicker steel on prongs, additional reinforcement around welds, but fundamental concept is proven. Over next 2 weeks, as more Rhino tanks deploy across Normandy, field reports stream back confirming initial success, but also revealing problems you need to solve. Some prongs are breaking off after multiple hedgerow breachings, steel fatigue from repeated impacts. Solution: source thicker gauge steel, add reinforcement plates. Some crews report prongs getting clogged with compacted earth and root masses, reducing effectiveness on subsequent breaches. Solution: add self-clearing mechanism inspired by agricultural equipment, angled plates that automatically scrape debris off prongs as tank moves. Some tanks using Rhino cutters in ways you never intended, smashing through brick walls in urban fighting, pushing disabled vehicles off roads, even clearing snowdrifts. Each application reveals new stress points, requiring modification. You're working 18-hour days now, traveling between units, observing Rhino tanks in combat, collecting feedback, implementing improvements. Welding crews back at production facility receive constant updates. New specification: increase prong thickness from 3/4 inch to full inch. Add deflector plates here for debris clearance. Reinforce these welds with doubler plates. Production tempo increases. By early July, over 300 Rhino tanks are operating in Normandy. General Omar Bradley visits production facility personally on July 7th. You're elbow deep in welding modification when aide announces, "Sergeant Cullen, General Bradley wants to speak with you." You drop welding torch, attempt wiping grease off hands, snap to attention as Bradley approaches. "At ease, Sergeant. I came to see man who unstuck my army." Bradley gestures toward Rhino tanks being modified. "Your invention is exactly type of innovation military needs. Simple, effective, built from materials readily available. More importantly, it works under combat conditions where sophisticated engineering solutions failed. I'm recommending you for Legion of Merit, and I'm authorizing immediate production increase. I want every Sherman in 1st Army equipped with your hedgerow cutter before Operation Cobra launches." "Operation Cobra, sir?" "Major offensive designed to break out of Normandy, scheduled for late July. Your Rhino tanks are critical to success because they'll allow armor to advance rapidly through bocage countryside without being stopped by hedgerows. Sergeant, your modification might have saved more American lives than any weapon we've deployed in this theater." But Bradley's visit also brings unexpected revelation. According to historian Max Hastings's later research, Bradley mentions during inspection, "Sergeant, there's some confusion about invention's origins. Private named Roberts from Tennessee supposedly suggested basic concept during brainstorming session, but you're credited with developing working prototype. Can you clarify?" You remember Roberts, hillbilly, as some called him, though you never liked that term, who'd joked during discussion, "Why don't we get some saw teeth and put them on front of tank and cut through these hedges?" Everyone had laughed, dismissing idea as simplistic. But you'd seen potential, recognized that crude concept could work if properly engineered. Sir, Private Roberts suggested initial concept during informal discussion. I developed that concept into working prototype, refined design through testing and implemented production. Credit should be shared, sir. Bradley nods appreciatively. Honest answer, Sergeant. Most men would claim sole credit. I'll ensure Roberts receives appropriate recognition. But as historical record shows, Roberts's contribution gets forgotten in publicity surrounding invention. You become American kind of national hero, exactly type of success story military needs for public morale. Enlisted man from New Jersey who solved problem using common sense and scrap metal embodied American pragmatism and innovation. But you know truth. Great ideas often emerge from collaborative discussions where someone throws out crude concept and someone else recognizes how to make it work. Innovation is rarely solo achievement, despite what history books claim. July 25, 1944, Operation Cobra launches. Over 750 Sherman tanks, approximately 60% equipped with Kulin Rhino cutters, participate in massive breakout offensive from Normandy. Your modification proves its worth immediately. Rhino tanks plow through hedgerow-defended German positions faster than enemy can reposition defenses. What would have been weeks-long slog through bocage becomes rapid armored advance. German defensive plans based on assumption that hedgerows would slow Allied armor are rendered obsolete. Within days, American forces break through German lines, beginning race across France that will eventually lead to liberation of Paris. Military historians later estimate that Rhino tanks shortened Normandy campaign by 3 to 4 weeks, saving thousands of Allied lives and preventing Germans from establishing new defensive lines inland. But personal cost comes October 1944. You're advancing with 2nd Armored Division through Hürtgen Forest in Germany when your vehicle hits landmine. Explosion is catastrophic, kills driver instantly, wounds others, and severs your left leg below knee. Medics save your life, but leg is lost. You're evacuated to field hospital, then to England, finally to United States for recovery and rehabilitation. War is over for you at 29 years old. You've received Legion of Merit for your invention, but you've paid price in blood. Physical rehabilitation at Walter Reed Hospital is brutal. Learning to walk with prosthetic leg, dealing with phantom pain, adjusting to new limitations. Psychological recovery is harder. Survivor's guilt plagues you. Why did you survive when driver died? Why does invention that saved thousands of lives matter when you couldn't save man sitting 3 feet away? Chaplain visits regularly trying to help process trauma. Sergeant, you can't control random chance of where mine was buried or who happened to be sitting in vehicle's path. What you can control is how you respond to adversity. Your invention saved lives. Your sacrifice in losing leg doesn't diminish that achievement. It adds to it. You gave everything, including part of your body, to defeat fascism. You want to believe that, but some nights phantom pain keeps you awake and you wonder if any of it mattered. Post-war life brings unexpected challenges. You return to Cranford, New Jersey, where local newspapers celebrate hometown hero who invented Rhino tank. But you're not hero in your own mind. You're disabled veteran struggling to adapt to civilian life with prosthetic leg and combat trauma. You take job as salesman for Schenley Industries liquor distributors, work that requires social skills you've never possessed naturally. Some days are good. You meet people, share war stories carefully edited to remove worst parts, feel almost normal. Other days, phantom leg pain is so severe you can barely function, and nightmares about burning Sherman tanks wake you screaming. Years pass. Korean War happens without you. You're 4F now, medically disqualified. Vietnam begins while you're working sales routes through New Jersey. Younger generation asks about your service, and you show them prosthetic leg, explain briefly about Rhino tank invention. Most are impressed. Few understand psychological weight of knowing thousands of men used equipment you designed, and some died despite your best engineering. November 20th, 1963. You die at 48 years old, too young, worn down by decades of phantom pain, alcohol use to cope with trauma, and survivors' guilt that never fully resolved. Obituaries mention your invention, Legion of Merit, contribution to Normandy campaign, family holds small funeral in Cranford. Former tankers who'd used rhino cutters send condolence letters, your invention saved my life. Without rhino tanks, we'd never have broken through German defenses. You were genius who changed how we fought. But you died thinking you were just mechanic who got lucky once. That's tragedy. You never fully comprehended your impact. Modern military historians recognize Colin Hedgerow Cutter as one of most significant tactical innovations of World War II. Not because it was technologically sophisticated, it wasn't. Because it solved critical problem using available resources and could be manufactured rapidly in field conditions. Your invention exemplified American military's greatest strength: ability to adapt quickly, empower junior personnel to innovate, and implement solutions from bottom up rather than waiting for top-down directives. Pentagon staff studies now teach your story as case example of how innovation happens in combat. Soldiers closest to problem often see solutions that distant experts miss. Museums display Rhino-equipped Sherman tanks as examples of battlefield innovation. National World War II Museum in New Orleans features your invention prominently. Cranford Historical Society maintains small exhibit about local hero who changed D-Day's outcome. Military engineering courses analyze your design, discussing why simple solutions sometimes work better than complex alternatives. Modern combat vehicles still use variations of your basic concept: steel blades or prongs mounted to front of vehicles to clear obstacles, breach barriers, or create pathways through difficult terrain. Every tank crew using obstacle-clearing blade is inheriting legacy you created with welding torch and scrap steel in 1944. Perhaps most significant legacy isn't technological but philosophical. Your story proves that military hierarchies must listen to enlisted personnel who often see problems and solutions that officers miss. Curtis Cullen wasn't general, wasn't trained engineer, wasn't West Point graduate. You were mechanic from New Jersey who understood that sometimes best solution is simplest one executed properly. Military establishment initially dismissed your idea as too crude, too simple, unworthy of serious consideration. But you persisted, built prototype anyway, demonstrated it worked, and forced institution to acknowledge that crude simplicity sometimes beats elegant complexity. That's lesson extending far beyond military applications into any field where institutional inertia prevents adoption of better methods. Innovation doesn't require advanced degrees or sophisticated equipment. It requires observing problems carefully, thinking creatively about solutions, and having courage to test ideas despite skepticism. You possessed all three qualities, plus mechanical skill to build working prototype and persistence to push through bureaucratic resistance. Without those qualities, thousands more Allied soldiers would have died trying to climb Norman hedgerows using conventional tactics that exposed them to German fire. Sometimes most important inventions don't come from laboratories or research facilities or military academies. They come from mechanics working with grease under fingernails, using scrap materials and practical knowledge accumulated through years of fixing broken things. You were that mechanic, Curtis Cullen, and your 48 hours of welding scrap steel onto damaged Sherman tank changed how modern armies think about tactical innovation, battlefield adaptation, and empowering individuals to solve problems institution couldn't solve through formal channels. The hedgerows of Normandy still stand today, centuries-old earthworks unchanged by war that swept across them 80 years ago. Tourist visitors walk Bocage countryside, photographing picturesque barriers that once killed men by hundreds. Few understand that these innocent-looking hedgerows were death traps requiring one mechanic's ingenious solution to overcome. Your Rhino tanks didn't destroy hedgerows. They gave Allied armies way to breach them rapidly enough that German defensive advantages evaporated. That's how wars are won, not through superior firepower alone, but through innovative thinking that renders enemies' defensive preparations obsolete. Your name isn't widely known outside military history circles. Most people who've heard of D-Day couldn't identify Curtis Cullen if asked. But every tank commander who's used obstacle-clearing equipment, every military planner who's empowered junior personnel to propose tactical innovations, every veteran who survived Normandy campaign because Rhino tanks enabled rapid advance, they're all inheritors of legacy you created. You died young, never fully recovering from physical and psychological wounds war inflicted. But your invention lived on, saving lives, changing tactics, proving that sometimes greatest military innovations come from least expected sources. Enlisted mechanics willing to challenge conventional wisdom and build better solutions from materials everyone else overlooked. That's how Mad Mechanic turned broken tank into engineering legend. Not through advanced education or sophisticated technology, but through observation, creativity, and refusal to accept that impossible problems have no solutions. You saw hedgerows killing Sherman crews, recognized that going through was safer than going over, and built device that proved your insight correct. Simple as welding steel prongs to tank's nose, complex as challenging entire military establishment to acknowledge that crude field modification was superior to any solution formal engineering channels had produced. Your 48 hours of work in June 1944 saved thousands of lives and shortened World War II's bloodiest campaign. That's not bad legacy for mechanic from Cranford who just wanted to stop watching good men burn in tanks.